Assalamualaikum warahmatullahi wabarakatuh. Okay, good morning, my students. In this occasion, I would like to introduce to you our microcontroller system, which is based on IoT devices, for example, this one. And we will try to program this microcontroller by using Micropython programming language. In the last meeting, I already introduced to you that the Python programming language is the most commonly programming used today. So that's why I encourage you to use MicroPython, which is a part of Python itself. Okay, next, this is the introduction of our expressive microcontroller system, this one. Okay, the microcontroller generally only have several components that integrated inside this microcontroller. This component, for example, the analog or digital converter, an oscillator, a microprocessor itself, a RAM, a program memory, EEPROM, and so on. Thus, this component can be used directly without adding another supporting component. For example, this one, we just need to connect the supply, the power supply, and then the microprocessor can be execute our program. Okay, the weakness of the one of the weakness of microcontroller is that because the need the function that don't need higher computational resources, that's why a microprocessor inside the microcontroller only capable to execute several tasks, not as the tasks that can be executed in the computer system. So that's why this microcontroller use a low computational core, for example, ARM M1, ARM M0 or M4. And this core only cost a small piece of silicon. So that's why the price can be lower than the high computational core. Okay. And this is our microcontroller. So I insist you to use the ESP32 microcontroller because this microcontroller system already built in with the Wi-Fi capability and also Bluetooth connection in one single chip. And also there is a multitude of module and board from different sources. So you can find the board that satisfied with your project. For example, there is a board that already include with the LoRaWAN. LoRa is mean for long range wireless connection. And also there is a board that include LED or LED display. And also there is a board that includes the Type-C connection and also the push button, and so on. So that's why this is very commonly found in the market. And then to make a generic ESP32 port support as many boards as possible, the following design and implementation decisions were made. For example, the GPIO pin number is based on ESP32 chips number. We can find the reference from the datasheet. And also all pins are supported by Micropython, but not all are usable on any given board. For example, actually the ESP32 have more than 20 pins, but because the board only small, so maybe the pin only consists of 20, below 20. Yeah. So that's why not all pin can be accessed in hardware. And then this is ESP32 from development full pin out. So as you can see, we have several GPIO here. We have also the power supply pin, for example, 3-volt and the ground. And also we have 5-volt pin and the connection from Bluetooth, Wi-Fi, and from the USB. So the power can be, this device can be powered using the USB cable. Okay, maybe this is the introduction of the ESP32. There is a lot of application that we can choose. For example, the IoT application can be made by using this component. And for the detailed technical specification of this SoC, you can see that the architecture is based on dual-core 32-bit LH6. So that's why this microcontroller is more can achieve more performance rather than using the previous Atmel, Atmega, or STM32. Yeah, because this microcontroller already included dual-core 32 bits microprocessor. And the frequency up to 240, the RAM available, wow, 500 kilobytes. As I mentioned before, that maybe compared with Atmega 32, the RAM, the lack of RAM of this microcontroller can be matched with this ESP32. And also the boot RAM, the external flash ROM, as you can see, 4 megabytes. It is enough for us, for example, to record the data, to record the sensor, and so on. And also we have 34 GPIO, UART capability, SPI connection, I2C connection, I2S connection, ADC, 12 bits. This is up to 18 channels. This is quite big. And DAC, 8 bits, and 8 channel of pulse transmit and receiver. And then we can also use Arduino IDE to program this microprocessor. But in this course, I will use Tony IDE, and we will program this microcontroller by using Micropython programming language. Okay, maybe that's all for the introduction. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.